Hi all students, welcome to Bright and Target Learning app. Myself Nishad, a faculty of chemistry in Bright Learning app, and
Myself, I am Urshad, Faculty of Chemistry, Target Learning app.
so today the NEET exam is over and you already know this today's exam was not much a great task, and today from the case of chemistry we have 45 questions and that 45 question is purely based on our NCERT. So if you know NCERT very well, definitely you will get the answers directly. When you're searching our videos in YouTube or in our app, you can see the same questions we discussed in our classes. So that same question is asking for the NEET exam. Surely the next year also, if you join with us, you will get a great marks. So today when we are going to the chapters, when we are going to the inorganic chemistry, initially we have P block. I'm just starting with P block. Why? Because the 5 questions, including the +1 P block and the +2 P block, there are 5 questions is from P block. And moreover from the organic chemistry, we have general principles and isolation, and the general some basic principles of chemistry, and also hydrocarbon, that is the first year organic chemistries, we have 2 questions, and also in the second year we have almost 8 questions, and we can probably say there is 10 questions approximately that is coming from the case of organic chemistry. And every chapters, the question is asking from every chapters, and it is very simple, humble concept, and if you know the NCERT very well, definitely you will get a great marks. Okay, so sir will explain you the questions each and every one, and I will also join with you. We can go through the questions directly. Okay. So sir, you can start right now.
So we'll go to the first question. So the question is, which of the following amine will give the carbylamine test? So the first question was related to organic chemistry, and that comes from the chapter amines. Okay. So you have an option like you have primary amines, secondary amines, and tertiary amines are given in options, and you know that for carbylamine reactions, it is answered by primary amines. So if you go for the answer 1, see, this is your primary amine. So all of the second one is a secondary amine, then you have a tertiary amine, again you have a secondary amine. So, sorry, it's a tertiary amine. So only primary amines will answer carbylamine reaction. So the answer will be option 1.
So I think you got the concept very clearly. And the question is directly from the carbylamine test, and we studied that carbylamine test in the chapter amines. The carbylamine test is only given by the primary amine, and the sir is explained that question. It will be formed only in the case of aniline. Aniline is a primary amine here. So I think we can go to the next question.
We'll go to the next one.
Yeah, sure. Actually, based on this question, the question is asking an alkene on ozonolysis gives methanol. See here. An alkene on ozonolysis gives methanol as one of the product, and its structure is, you have to form ozonolysis. And definitely when you're going to this question, and we got this question from the
it comes from hydrocarbons. So it's used to distinguish the presence of double bond in an organic compound. So we can identify the position of a double bond in an organic compound by the reaction called ozonolysis, followed by hydrolysis using zinc dust. So we have, like, on ozonolysis, we'll be getting a mixture of products like aldehydes or ketones, and that depends on the position of double bond. So one of the product obtained here is methanol, which you know that it is HCHO.
Yeah.
So if you are going for the first compound, if you go for the first compound, your product will be CH3CHO, because the cleavage or the bond cleavage occurs between the carbon atom, like the second and third carbon atom of the long chain. And if you go for the second compound, it does not carry a double bond on the aliphatic chain, but it has a double bond on the benzene, inside the benzene ring. So ozonolysis will not be getting the desired product like methanol. And if you go for the third compound, like you have the double bond between the first and second carbon atom of the long chain compound. So definitely the ozonolysis takes place in between that 2 carbon atom, and you'll be getting an ozonide. And on further reaction with zinc, see, this CH2, that will produce the methanol like HCHO. Well, we'll write the product as CH2O. You'll be getting like CH2O, and that product is same to that of HCHO. So methanol, the product is obtained from option C. And if you go for the the fourth one, and there also the double bond is present inside the ring, inside the cyclic ring. So if you go for that compound, you'll not be getting methanol. Instead, you'll be getting some other cyclic compounds. So the correct answer for this question will be option 3.
So actually, sir, this question is directly from our ozonolysis.
Ozonolysis. So it's a direct question from our hydrocarbons. So
Yeah.
it's just
So-
to identify the position of that double bond.
Yeah, Jisha, very good. And actually, and this thing is a normal question, and
Exactly,
we are
exactly.
and we, even though for your our in a public exam also we are discussing the same thing. Same type of question is asking, and it was a very simple question. When we are getting to this question, we will think it is a tough. But ozonolysis, if you know that concept very clearly, it's a very simple question. So now let us go to the next question.
To the
sir.
next question.
Okay. Actually, see here question. This is a question that we can say about. It is a mixed question, and it is most probably is the question is from hydrogen. Hydrogen is a chapter that is our chapter of our grade 11, and it's a 7th chapter. And when we are going to this chapter, it is given by CO plus H2. You know that CO plus H2 is known as synthesis gas. So you got the first one. The CO plus H2 is known as a synthesis gas. And you know the concept of temporary hardness and permanent hardness that we studied in a chapter hydrogen. The temporary hardness is due to calcium or magnesium bicarbonates, and the permanent hardness is due to calcium or magnesium sulfates and chlorides. But here it is given that is the temporary hardness of water. So the temporary hardness of water, we will get the concept of MgHCO3 twice plus CaHCO3 twice. So when we go into the B2H6, the B2H6, we can say we studied the types of hydrate. That is, there are different types of hydrate. That is electron deficient, electron precise, electron rich. These are the three sets of hydrates that we have to discuss here. When we are going to the B2H6, so that is a very simple concept. B2H6 is an electron.
Diborane.
Yeah, diborane. Diborane shows banana bond. That banana bond structure that having 3 center 2 electron, the concept along the middle part, that is the along the bridge. You studied that concept, it having 3 center 2 electron.
It's an electron deficient molecule.
Yeah, it is the electron deficient hydrate. So you got that concept that B2H6 is a electron deficient hydrate. And also in the case of H2O2, it have a open book like structure.
Open notebook.
Yeah,
Partially open notebook like structure.
Yeah, open book like structure. So we can say H2O2 is a non-planar structure. So the answer we got, that is A43, that is A3. Then we get B1, that is B1. Then C2, that is C2, and D4. And when you know the concept of the chapter hydrogen, it's a very simple question. I
And
think.
also, see, they don't want to go for the option C and D, because by first and second option, they'll be getting the right answers, A2 and B1.
B1,
And
yeah.
we don't have any other option with A2 and B1. If you go for the rest of the options, so A3 and B1, you have only option. So that will be the right answer. So they don't want to go, actually they don't want to go for the next two option like C and D.
Yeah, that's right. So to minimize your time, you have to just go through the A and B, and definitely there is nothing more questions, that is nothing more in that option with the A and B are right. So you can directly go to the answer. So when you're students, when you're looking at this question, it's a very simple question. Okay, now so now let us go to the next question based on this one.
So it's a question from solutions.
Yeah.
So the question is like, the freezing point depression constant of benzene is 5.12 Kelvin kilogram per mole. The freezing point depression of the solution of molality 0.078 molal containing a non-electrolyte solute in benzene is. And you also want to round off it up to 2 decimal places. So it's a very direct question. You are asked to calculate the depression in freezing point, delta TF. And you know that the equation delta TF is equal to Kf into M. Delta TF is equal to Kf into small m, where M stands for molality. And you are provided with delta TF, like it is, our Kf value is 5.12 Kelvin kilogram per mole. And also for the molality, the value is something around 0.078. So we can calculate like 5.12 into 0.078. And if you go for the answers, you have a wide range like 0.2, 0.8, 0.4 and 0.6. So no issues if you go for minor approximation. And also you want to approximate into 2 decimal places. So what we have to do is like 0.078, you can approximate to 0.08. So your answer will be like 5.12 into 0.08, right? So it's something like 5.12 into 8 into 10 to the minus 2. Okay, 5.12 into 8 into 10 power minus 2. So you just approximate 5 into 8. That will
40.
be like 40. 40 into 10 power minus 2. So your answer will be like 0.4. So you have an option like option 3, 0.4 Kelvin. Okay. So it's very easy. They don't want to go for like 0.078. Just
Yeah.
by approximating that digit, they'll be getting the right answer, because you have a range of answers, 0.2, 0.8. It's
With
not
respect to
close.
the 2 decimal points.
Yeah, that's it.
Okay, so see here, students. Actually, this question is a direct question. If you know that equation, that is delta TF is equal to KF into molality, is a very simple question. And this question is directly from our chapter solution. That is grade 12 chapter. There's a second chapter. That's a direct question that is based on the molality. That is the freezing point question, and you can directly do that question. So now we can
we'll move on to the next one.
Next question.
So the option 3
Yeah,
will
3 is
be
the
the right
answer for
answer
this
for that one. Now,
So see here, students. So when we are going to this question on electrolysis of a dilute sulfuric acid, using platinum electrodes, you are given by platinum electrodes. So you are undergoing electrolysis of sulfuric acid using platinum electrodes. The product obtained are, that's the question is given here. What are the product will be obtained? So the product you have to obtain in the anode that you have to find. So when we are undergoing the electrolysis of sulfuric acid, actually when we are going to this question, actually this is we cannot say this is a direct question, sir.
so I think it's a question like coming from a little bit of outside.
Yeah, this question is not at all a direct question. This question we can see that is actually we studying this type of electrolysis method,
but they are studying the electrolysis of acidified water.
Yeah. So we are studying the electrolysis of acidified water and everything. So based on that question, you are just asking the electrolysis of sulfuric acid.
Yeah, that's it.
So we can directly say the answer, sir. We can say here that is the anode. The anode will contain oxygen.
Yes.
So and the cathode will contain the hydrogen gas.
They're using this reaction for the preparation of hydrogen gas. So hydrogen that will be liberated at cathode.
So hydrogen, in the case of hydrogen, that is, we can say this is second question that is based on the hydrogen.
Yeah, hydrogen.
And the hydrogen that you already know, there are different preparation. Actually, the first preparation that is already studied, that is the electrolysis of the normal water. We can do that acidified water.
And also they are going for the ultra pure hydrogen by barium hydroxide.
So that is also the second method. That is the electrolysis of barium hydroxide will also produce hydrogen. And we can consider this is also the preparation of hydrogen. And this hydrogen will be liberated at cathode. Don't misunderstand the concept. The hydrogen will be always liberated at cathode. And here we have to find what will be liberated at anode. Here the oxygen gas, that is the oxygen, is liberated in the case of anode. Oxygen will be liberated at an anode. This concept that you have to know. Okay. So, sir, now let us go to
the next question.
Question
number 6.
Okay,
so,
fine.
they need to identify a compound. They need to identify the compound X in that sequence.
Actually, sir, this question is based on our chapter that is aldehyde,
That
ketone
comes
and
from
carboxyl.
aldehydes and ketones, like
and
the preparation of
carboxyl.
aldehydes.
Yeah, preparation of aldehyde by the method. What is the method, students? This is the method of preparation by side chain chlorination.
Followed by the hydrolysis.
Yeah. First of all, you are doing the side chain chlorination, and further you are doing the hydrolysis, and you have to find the X here. So here you have to find the X, that is you are given by the benzene ring with CH3 that is reacting with the chlorine in the presence of HNU. You are forming a product here. You have to find what will be the product is forming here. Actually, when we are going to our NCERT, the same reaction you can see in the page number that is 363. In the 363, in the page number of NCERT, the grade 12 part 2, you can see the same reaction. Without any change, you can see the same reaction. That is, you are given by the toluene. The toluene is reacted with the chlorine. You are given by the toluene. The toluene is reacted with the chlorine here in the presence of HNU. It will form a side chain chlorination to form dichloro compound. So we can say here the answer, that is, it will form a dichloro compound here. We can say here that is CHCl2. And further hydrolysis, it will form benzaldehyde.
So that they can confirm that the product is like C6H5CHCl2.
Yeah,
it's a very direct question.
Yeah.
Normally we are not getting such questions from organic chemistry.
Yeah, sure. Always sure, because we never get this type of a question is from organic chemistry. Actually, when you even, that is the going students also, definitely they have to get good marks.
Anyone can answer this question.
The going students also will get a good marks when you are going to the normal concepts and everything. So
the option, it will be right.
Yeah, the options will be what will be the options here,
So,
students?
answer.
It will be 3 will be the answer.
Okay.
Okay, that's right.
I will
now.
move on to the next one.
Next one. Okay, fine.
So it's a question from basic concepts of chemistry. Anyhow, all the students, they will be like, they know how to calculate the number of atoms, number of molecules, the interconversion like mole, volume, weight in gram. Okay. So the question is related to which of the following has the maximum number of atoms. So they have provided like 1 gram of gold, 1 gram of magnesium, 1 gram of O2 and 1 gram of lithium. And see, they have provided the atomic mass also.
Yeah.
Actually, it's not required that the student should know the atomic mass.
Yeah.
So it's a very direct question. So we have an equation to calculate like the number of atoms. So the number of atoms, we have the direct equation like given mass like divided by Avogadro number. So that will be the equation used to calculate, given mass divided by capital M. Small m divided by capital M into Avogadro number. That will be the equation used to calculate the number of atoms. And see, these all are like silver atom, magnesium atom, then O2. For O2, we have to consider the atomicity because for O2 it's a diatomic
condition.
So if you go for the first question, so 1 gram of silver. So the number of atoms in 1 gram of silver will be like 1 by 108 into Avogadro number. Okay, so that will be the answer. We don't want to go for the final answer. Anyhow, we'll see which is the largest value.
Yeah, you have to just check the values only in the denominator section.
So the second one, like 1 gram of magnesium with atomic number 24, it will be like, it given mass like 1 divided by 24 into Avogadro number will be the answer for that one. So it is Na by 24 and first option you got Na by 108. So we can cancel this one because it is Na divided by 108.
It's a greater value.
So 1 gram of O2 with atomic mass of oxygen is equal to 16. That will come like 1 divided by 32 into Na. And here we need to consider the atomicity. Because for oxygen, it's a diatomic molecule. So for diatomic, each O2 will have 2 atoms. So it will be, we have to consider like into 2. So your answer will be 2 by 32 or 1 by 16. 1 by 16 into Na, right sir? 2 by 32 into Na, so it will be 1 by 16 into Na. And for 1 gram of lithium, it will be like 1 divided by 7 into Na. So you have some options like 1 by 7 into Na, 1 by 16 into Na, then you have 1 by 24 into Na and 1 by 108 into Na. So you need to identify the largest value. It's a very direct question, like your answer will be like the lowest value in the denominator.
That is D will be the answer.
D will be the answer.
That 1 is 1 gram of lithium with atomic mass of lithium is equal to 7. That will be the right answer. And this is a very simple concept that is based on our chapter. That is some basic concept of chemistry.
Okay, so students, they don't want to go apply the value of 6.022 into 10 power 20. It's not required. Just by comparing all these 4 values, they can identify the largest value. So the option is option 4 will be the right answer.
Right answer. Okay, fine.
Okay.
So
yeah, we can go on to the next question.
Identify the correct statement from the following. You are given by wrought iron is impure iron with a 4% carbon. Actually, you have to find the correct statement of the following. This is not a wrong statement. And initially from the concept itself, the wrought iron, this is a wrong concept. Actually, the wrought iron does not contain the 4% of carbon. You have to know the concept that is the pig iron. The pig iron having the 4% of carbon. That's the concept. Pig iron consists of the 4% of carbon. Wrought iron is the purest form of iron. So the purest form of iron never contain that much percentage of carbon. That's the concept for the first one. And the blistered copper, why we can say that is a blistered copper? Actually, in the case of blistered copper, we have the equation Cu2S plus Cu2O will give Cu plus SO2. Cu plus SO2 will be the answer. Sorry, this will be 6Cu, I think. Yeah, 6Cu plus SO2. For balancing, we can do 6Cu plus SO2. Actually, due to the presence of this SO2, this copper having a blister appearance. Blister means something shining appearance. This shining appearance is due to the presence of sulfur dioxide, and that concept, actually this concept you are studying in the chapter metallurgy, that is general principles and isolation of metals. Definitely. That's a chapter in the, that is grade 12.
That blistered appearance is due to the evolution of SO2 and not by CO2.
So this is a wrong concept. The evolution of CO2, this is a wrong concept. So the first one is wrong. I gave you the concept. Wrought iron is not 4% of carbon. This is also wrong.
Wrought iron will be the purest form of iron.
Okay. So we can go to the next one. Yeah. Vapor phase refining is carried out for nickel by Van Arkel method. That's a very wrong question. The Van Arkel method is only
up to nickel. It is correct, but the method is wrong.
The method is wrong. It is used for zirconium and titanium. The Van Arkel method is used for zirconium and titanium in the presence of iodine. We are using, sir. That is Zr plus 2I2. You know that equation, very simple. That is a very simple equation. I'm just taking here the concept. That is, you are given by Zr plus 2I2 will give Zr I4. That is zirconium tetraiodide. And when you are heating that zirconium tetraiodide, it will become Zr plus 2I2 again, and this Zr will be highly pure, and this is a method of refining. This is a method of refining that is based on our chapter, that is metallurgy. And when we are going to the next one, the pig iron can be molded into variety of shapes, that is given in our NCERT in the page number 161. Students, you can check there in the page number, in the second paragraph it is given that page number 161 it is given that is pig iron you can mold into different variety of shapes. That's a very simple question that is directly from our NCERT.
You have that direct that line itself it is giving.
Yeah, same line. There is nothing changed. The same line is given in our NCERT. That is the pig iron can be molded into a variety of shapes. Okay. So I think
the correct statement will be
the correct statement will be the 4 will be the answer. All the 3 concept is wrong. So I think it's a very simple question. Very simple question.
Because they have asked like blistered appearance, then they go for nickel van Arkel method. Because otherwise they can identify that these are the wrong statements also. So they don't want to get confused with the options.
Yeah. Very sure, sir. Very sure.
So we'll move to the next one.
Next question. Okay, fine.
So it's like a tertiary butyl carbocation is more stable than a secondary butyl carbocation because which of the following reasons? Okay. So they have provided like reasons like minus I effect, minus CA3 effect, R effect, minus CA3 effect, then minus R effect and CA3 groups and hyperconjugation, something like that. So it's something related to carbocation. So we know that the stability of carbocation. The stability of carbocation is of the order like tertiary greater than secondary greater than primary. Now this is the order of stability of different carbocations. And you know that the tertiary carbocation, the carbocation with the highest stability. And there are 2 possible reasons for the stability of carbocations. Like one will go for the hyperconjugation and the inductive effect. Hyperconjugation effect, and second one is the inductive effect.
And so also, sir, can I ask you one doubt?
Yeah.
And actually here that inductive effect is plus inductive effect.
Yeah, it will be plus because the electron will be moving from the methyl group to the carbocation.
Yeah.
So electron is moving towards the carbocation. So that CA3 group is supplying. So that will be the positive inductive effect.
Okay, fine.
So here they have given inductive effect, but they are considered only minus I effect. So it will be just the reverse.
Oh,
it's not happening there.
Okay, fine.
But we can go for the hyperconjugation effect. So in a hyperconjugation effect, if you go for a carbocation, something like C plus, and we are having CA3 groups. So this is one something like a tertiary carbocation. So here it is also known as the sacrificial conjugation. So here total we have 9 hydrogen atoms which are able to sacrifice.
Yeah.
So you'll be having like double bonds. So if you are having double bond in this location, or you can have in this location or in this location. So if you go for the resonance in tertiary carbocation, you'll be having a total of 9 resonating structures will be possible.
Because in the 3 that is 3 branches.
Yeah, because of since it contains 3 CA3 groups.
Yeah.
But if we go for the secondary carbocation like C plus, right over here.
Yeah, sure.
C plus, and you are having 2 CH3 and 1 hydrogen atoms. So if we go for the resonating structures, you'll have only 6 resonating structures. So a structure with more number of resonating structures will be more stable.
Yeah.
So anyhow, the question is, we don't want to go for such options because the effect is like plus R effect and hyperconjugation. So the answer is very much clear that option D will be the right answer.
So that is the question that is asking, that is based on the stability of the carbocation.
So it will be due to hyperconjugation. So they can rule out that minus I effect.
Yeah,
because
here they are showing only the cases of plus I effect.
Plus I effect.
Okay, fine. So actually this is also a question directly from our chapter, that is our chapter, that is general
hydrocarbons.
Okay, hydrocarbon chapter. Okay, fine. So
no, it will be from our first chapter.
That is organic chemistry, some basic principle. We are studying this concept of inductive effect, resonance effect, hyperconjugation, and everything. And actually, this question is directly from that concept, the carbocation. You get the concept of a hyperconjugation, and it is not based on the negative inductive effect. It is showing the positive inductive effect.
And also, sir, it's provided in the textbook.
Yeah.
Because the tertiary carbocations are more stable due to inductive effect and hyperconjugation. The statement is very clear in the textbook. So this time they have stick on with the NCERT text.
NCERT textbook. And also, sir, we can next year also we can think like that, because always the NTA is looking for based on your NCERT.
The syllabus is based on NCERT only.
Yeah, fine.
We have to stick on with the NCERT text. The students should by heart the text. That's it. Okay. Word by word they should know the points.
Okay. So students, I can recommend you one thing, because the next year also there will be a good class you can get from even the Bright Learning app in the case of Target Learning app. And from the Middle East students, you can suggest that is the Bright Learning app. And for the Indian students, especially from the Kerala students, students, you can select that is the target learning app. And this, I think, sir, you also that is go with the all type of questions in the class during
Definitely.
crash
In our
classes.
crash classes, we have discussed such questions.
Yeah, fine, sir.
I think most of the questions that
That
we have
discussed here.
Came
Okay,
this time.
Okay.
Yeah, it's like.
Okay, now let us go to the next question. Actually, sir, this question is based on the reaction of the ammonia condition. So when we are going to this question, see here the concept. When you are going to this question, urea reacting with water to form A. That is, the urea is reacting with water to form A. Urea. What is meant by urea? You have to know that concept. Urea is NH2CO NH2. That is known as urea. So urea reacting with water to form A compound, which decomposes to form B. That is, which is reactive with the water A, it will form, that is ammonium hydroxide. Ammonium hydroxide will be formed here, and which will be decomposed to B. So what will be decomposing here? It will be decomposed to ammonia. Ammonium hydroxide will be decomposed to form B, means here the B will be ammonia itself. And the B, when passed through a copper, when the B you are passing through copper, a deep blue color, actually we are studying this reaction of metal ion, that is reaction of metal ammonia in the case of chapter that is S block, sir. In the S block, we are studying this type of reaction with the metal ammonia. That is, the copper is the same condition here that we are discussing there itself. That is, the copper is reacted with the ammonia. It will become, that is, a complex of copper, that is copper and ammonia, that is CuNH3 4 times all power 2 plus.
It's having a characteristic color also.
Yeah, it having a characteristic color of blue. And it will be diamagnetic, I think so.
Yeah.
This is diamagnetic, and further when we stand this solution for a long time, it will be changed this color and it will become paramagnetic. And we studied that concept in the chapter that is S block. And if you know
reaction
that
with liquid ammonia.
Liquid ammonia, yeah, fine. That is M plus X plus Y NH3.
So actually, this question, you know, it covers like S block. It covers coordination compounds.
Yeah.
Most of the section tests, and this also, like it's one of the tests used to identify the presence of copper ion. So copper ion, when made to react with ammonia, it will give a deep blue color. It's also mentioned in coordination compound.
Coordination compound, also the same type of questions we can get. Actually, it's a mixture of two chapters. Actually, this question is a mixture of your grade 11 chapter and the grade 12 chapter. The grade 11, the same concept you are studying in the chapter of S block, and the grade 12, you have to know the same concept in the chapter of coordination compound. So if you know the one chapter clearly, it's a very simple question, direct question.
It's a very direct question.
And also you have to know this copper having the ammonia having the blue color. And what will be the color of copper sulfate? You know that concept, so you can say what will be the color of...
Yeah, that will also be blue color.
Yeah, so the copper sulfate also will be the blue in color. And here also the urea is given in this question. Urea, that is NH2CONH2. So that is reacted with water, it will form ammonium hydroxide. The ammonium hydroxide decomposes to form ammonia, and that ammonia is reacting with the copper. It will form a complex of copper, that is copper with the tetraamine with the 2 plus. This is a compound is forming here, and they will be having a characteristics color of blue.
Yeah. And also for 2019, for NEET examination, they asked this question, like the formula of CuCO3.COH twice, like malachite. What will be the formula of malachite?
Malachite, yeah. Malachite, that is a question is based on our metallurgy chapter.
Yeah, metallurgy.
Metallurgy, so that is the name of the ore.
They are more concentrated with malachite, I think.
Yeah, yeah. Also, that's if you know that concept of the last year, and this is a direct question, that is the malachite and concept, and also students. Especially that is today in this year there's a question is directly from our P block chapter.
Yeah.
And also I think there is also named reaction is given in our organic chemistry also.
Many reactions.
The named reactions like cross-aldol condensation, and also in that option.
It's all the questions that we can expect, like aldol condensation, cross-aldol condensation, ammonolysis. These are the reactions that we can expect for, but directly such questions also okay.
Yeah, fine. So sir, shall we
move to the next
question? Okay, fine.
So it's some like that question came from states of matter.
Yeah.
Okay. For states of matter, usually we'll be having some complicated questions, something related to the
actually the end part of the chapter, that is TC. That is the critical constant.
Carbon dioxide. Yeah. Some questions will be there, but this is a very direct question. Like a mixture of N2 and argon gases in a cylinder contains 7 gram of N2, 8 gram of argon. Now, if the total pressure of the mixture of the gases in the cylinder is 27 bar, so P total is provided. P total, they have given that's equal to 27 bar. the partial pressure of N2. So you know that like the partial pressure means the pressure exerted by a single component from a mixture of components. So they are asking, you have a mixture of gases like N2 and Air, and you know that N2 and Air, they will not react because they are like non-reactive gases, because argon, that belongs to group 18. So that
stable element,
yeah, because here we are considering the concept of Dalton's atomic theory. So it is applicable only for non-reactive gases. So that's why they have considered N2 and Air. Now we have to calculate the partial pressure of N2, Pn2. And we have a direct equation for that one, like Pn2 is equal to P total into mole fraction of N2.
Yeah.
So that we have to calculate, the only thing is that we have to calculate the mole fraction of N2, and you are provided with P total. So mole fraction of N2, if you go for the mole fraction of N2, that will be equal to number of moles of N2 divided by number of moles of N2 plus number of moles of like argon.
Argon, yeah, okay, fine.
Okay.
That is total number of moles.
Total number of moles. Like, and also they have provided like the atomic mass of nitrogen and argon.
And the given mass also.
Given mass also. So your calculation, their calculation will be something like, for number of moles of N2, like 7 divided by 40.
Yeah, the given mass, not 28, sir.
Yeah, 7 divided by 20.
28.
N2.
Okay.
So that it will be given mass 7 divided by 28.
All divided
by 7 by 28. Plus then number of moles of argon will be 8 divided by 40.
Yeah. Actually, students, why here they are taking as 28? Actually, this is a diatomic molecule. Nitrogen is a diatomic molecule here. And in the case of argon, it is a monoatomic. So here we can say that is 8 by 40 in the case of...
so it's better to take 1 by 5.
Yeah, 1 by 5.
Instead of 8 by 40, they can take 1 by 5. And 28 into 5 can be taken as the LCM over here. Yeah, so that will be that's how they can calculate it. So their calculation will become 7 by 28 divided by, so 7 by 28 plus 1 by 5.
1 by
so
5.
Let them take like 28 into 5, that's the LCM.
Okay.
So they can do like 7 into 5, so it will be 35, right sir?
Yeah.
35 plus 8 into 5 they have to do, right? So 28 into 5 or, 8 into, no.
Actually, it is 7 by 20.
So it will be 1 by, so that will be 28.
Yeah, 28 only there will be.
Divided by 28 into 5.
Okay, fine. That will be the correct.
So that will be the, so if they are going for that calculation, their answer will be something like 5 by 9.
Yeah, the final, by
you
are simplifying the answer,
that answer
you will get an answer of 5 by 9.
Because 28 and 28, that will be easily that get cancelled. So that get an answer like 5 by 9. So they can directly substitute that 5 by 9 here. So P total is 27 into 5 by 9.
Okay, that's a direct question.
So yeah. So they can cancel like 3 into 5. Though yeah, they had the option.
Yeah, 15 3 into 5 it will be go to 15.
The only thing is that they should be able to solve this one. That they should be able to calculate the number of moles or the mole fraction of N2.
Actually, sir, for this question, how many minutes you are expecting to complete this question?
Maximum 2 minutes.
Maximum
2 minutes.
Okay. Actually, students here, some questions you do not need to be thinking too much. In between, that is less than 30 seconds is needed for some questions. But some questions you have to put that more time for that this type of problematic question. So you have to be sharply stick on the questions in the case of problematic. In a small minute mistake will change your answer, because all these answers are that is related. That is 9, 12, 15, then it becomes 18.
And also they should not go from here like 7 by 28. They should not go for the answer.
Don't go for the points like that. Try to cancel that everything, and finally you will get the correct answer. Always do with the don't do with the decimal points. Always do in the case of fractions like that. Okay. So actually this is also a direct question that is based on our chapter, that is the states of matter.
Matter.
Okay.